Day 828 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1140, Stone Game 2. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Alice and Bob continue their games with piles of stones. There are a number of piles arranged in a row, and each pile has a positive integer number of stones. Piles of odd, the objective of the game is to end with the most stones. Alice and Bob take turns with Alice starting first. On each player's turn, that player can take all of the stones in the first X remaining piles where 1 is less than or equal to X and X is less than or equal to 2M. Then we set M equal to the maximum of M and X, and initially M is equal to 1. The game continues until all of the stones have been taken. Assuming Alice and Bob play optimally, return the maximum number of stones Alice can get. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input piles equals an array of integers 2, 7, 9, 4. The output is 10. Now, Alice goes first, and we want to see what is the maximum number of stones Alice can get. Now, Alice can pick X stones to start, but X has to be greater than or equal to 1 or less than or equal to 2 times n. So in this case, m is equal to 1. So Alice can either pick 1 stone or 2 stones, right? So let's look at the explanation so we can see what happens if she picks either one. So it says if Alice picks not 1 stone, but 1 pile. It says if Alice takes 1 pile at the beginning, Bob takes 2 piles, then Alice takes 2 piles again. Alice can get 2 plus 4 plus 4, which equals 10 stones in total. If Alice takes 2 piles at the beginning, then Bob can take all 3 piles left. In this case, Alice gets 2 plus 7, which equals 9 stones in total. So we return 10 since it's larger. So let's break this down one step further. Boom. Let me copy and paste this over here. This is the input array. Then we'll come over here and say A equals for Alice and B equals for Bob. Boom. So if Alice takes this at the beginning, boom, we'll take this. We'll just put this here next to Alice. Boom, Alice has 2 points. Now, remember, Alice took 1. So now we set the maximum of 1, so now we set M to the max of 1 and 1, since this was already 1. Since M was already 1, the max is just of 1 and 1, which is still 1. Which, since it's still 1, that means Bob can still take 2 piles. So since Bob, because 2 times 1 would be 2. So Bob can take 2 piles, and Bob is going to go for these 2. Boom. So now Bob takes 7 plus 9. Boom. Now, I guess it doesn't really matter how many points they have. We just want to return the maximum number of stones Alice can get. It doesn't really matter how many points Bob has. It doesn't matter if Bob has more points or not. We just want to know the maximum number of points that Alice can get. Then Alice could come through and get these 2. After Bob got these 2, right? So now M becomes 2. Boom. So now, really, Alice could take 4. And then, what was that? The max, if he took 2, then, the max would be 4. So now M is 4, I think. Because, yeah, he took 2. Boom. So that means X would be 2. So X would be 2. And then M would be 4. Sorry. Right? We're looking right here. Boom. So now M is 4 either way. But either way, it doesn't matter because Alice is going to take these last 2. Boom. She doesn't even need the whole 4. And we'll go 4 plus 4 equals 10. Boom. So that's if she took the first pile at the beginning. Now let's go through it. If she took the second pile at the beginning, boom. I mean, if she took 2 piles at the beginning, not the second, but 2, boom. So we'll just copy and paste this again. Then we'll say Alice. We'll say Bob. And boom. So let's say Alice takes these 2 first. Boom. Alice takes these 2. Now she has 2 and 7. Boom. Then we're going to come underneath this. Oh, we're not going to come underneath this, but let's just set the M equals the max. Alice took 2. So, and that was 1. That was the first go. So, 2. Boom. So now M is, sorry y'all. After this, M is now equal to 2. Boom. Now that M is equal to 2 and Alice already went, it's Bob's turn. And that means Bob can take 4 moves, right? Because it's 2 times N, or 4 piles. So since Bob can take 4 piles, he's just going to take the rest of these 3. Boom. After he takes the rest of these 3, so sorry, Bob gets all of these. Boom, because he can take 4. So Alice is left with 9. So since this was the optimal move, the first one, or since this was allowed Alice to get more stones, we're just going to return this because 10 is the maximum amount of stones that Alice can get, right? 10 is greater than 9. So just in case that didn't make sense, let's take a look at example 2. If example 2, we're not going to go through it as in depth as we did up here, but you can if you want to. But in example 2, we have our input piles equals an array of integers 1, 2, 3, 4, 5, 100. The output is 104. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. So let's see. The first thing we need to do is we need to get the number of piles in the game. So we'll come right here. We'll say let n equal piles.count. Boom. Now we need a 3D memoization array used to store previously calculated results. So we're just going to declare a variable called memo and set that equal to an array, open up the parentheses, repeating, colon. It's going to be repeating another array, so it's going to be a 2D array. Then we'll see, actually it's going to be a 3D array, so get ready for another array, because this array is going to be repeating another array, and we're going to open up the parentheses again. Then this time it's going to be repeating, colon, -1, comma, count, colon, n plus 1. Then we're going to come outside of this. We're going to say, comma, count, colon, n. Come outside of this, comma, count, colon, 2. Sorry, y'all, that should be a 2. Boom. Then we'll come underneath this, and we're going to write a recursive function that determines the maximum number of stones Alice can collect from the current game state. So we're going to declare a function called solve, open up the parentheses, underscore person, colon, int, comma, underscore I, colon, int, comma, underscore m, colon. That's going to be an integer as well, and we're going to return an integer and open up the brackets. Now, if there are no piles remaining, Alice cannot collect any additional stones. So we're just going to say if I is greater than or equal to n, we'll open up the brackets and return 0. Boom. Then if the exact game state has already been calculated, return the same result instead of calculating it again. So we're going to say if memo, square bracket, person, come outside of that square bracket I, come outside of that square bracket m, does not equal -1. We're going to open up the brackets and we are going to return memo, square bracket, person, come outside of that square bracket I, come outside of that square bracket m. Boom. Alice wants to maximize the number of stones she collects, so her result starts at 0. Bob wants to minimize the number of stones Alice eventually collects, so his result starts at the largest possible integer. So we're going to come underneath this, declare a variable called result, set that equal to person equals 1, question mark 0, colon, and dot max. Boom. Now we're going to keep track of the total number of stones taken if the current player chooses X pile. So we'll come underneath this, declare a variable called stones, set that equal to 0. Now the current player can take anywhere from 1 to 2 times n piles. So we're going to say 4x and 1 dot 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 min, open up the parentheses, 2 times m minus n, or comma, n minus I. Come outside of that, open up the brackets, and add the next pile to the running total. So we're going to say stones plus equals piles, square bracket, I plus x minus 1. Boom. We're not done yet, though, because after taking x pile, the new value of m becomes the larger of the previous m and x. So we come underneath this, we say let next m equal max, open up the parentheses, m comma x. Boom. Then we'll come underneath this, and we'll say if person equals 1, we'll open up the brackets, and Alice's turn. Alice receives the stones she takes now, then Bob plays starting from the next available pile. So Alice tries every possible X and chooses the option that gives her the most total stones. So we're going to say result equals max, open up the parentheses, result, comma, stones plus solve, open up the parentheses, 0, comma, I plus x, comma, next m. Boom. Then we'll come right here and we'll say else. We'll open up the brackets, and it's Bob's turn. And we are only tracking Alice's total score, so the stones Bob takes are not added to the result. Bob plays optimally and chooses the move that leaves Alice with the smallest possible final score. So we're going to say result equals min, open up the parentheses, result, comma, solve, open up the parentheses, 1, comma, I plus x, comma, next m. Boom. Then we're going to save the result for the state so that if we encounter the same person again, we can reuse it. So we'll come underneath this, and we'll say memo, square bracket, person, come outside of that, square bracket, I, come outside of that, square bracket, m. We'll set that equal to result. Boom. Then we're going to return the maximum number of stones Alice can eventually obtain from this game state by saying return result, y'all. Boom. That is all. Oh, actually, that's not all she wrote yet, because we still need to call the helper function by saying return solve, open up the parentheses, 1, comma, 0, comma, 1, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs properly. Ooh, we got an error. Let's see. It's a lot going on up here. So here it is right here. Boom. Now let's give this a run. See if that fixed it. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted. And look at that, y'all. 22 milliseconds beats 50% of users. Not too bad. Not too bad at all, y'all. So with that being said, y'all, before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.